Operation 1. Initial pressurization. To introduce carbon dioxide into the system, attach the CO2 cylinder to the fitting situated at the top right of the trolley, behind the collectors. Upon opening the cylinder, carbon dioxide flows through the pipework, directing it either to a manual valve labeled as MV1 or an alternative automated valve that's managed by the software. Operation 2. Pressurization of the CO2 pump. On opening MV1, the CO2 travels through the valve, passes through the condenser, and ultimately reaches the pump. As the CO2 passes through the condenser, it is cooled to ensure it maintains liquid form. Although the pump can handle compressing gas, it operates more efficiently with a liquid. Operation 3. Pressurization to the vessel inlet. The carbon dioxide travels from the pump, through the preheater, and to the vessel valves, MV4 and MV7. The preheater warms up the CO2 prior to its entry into the reaction vessel, thereby ensuring consistent conditions throughout the process. At this juncture, it's vital to avoid starting the pump, as it might unintentionally set off a rupture disc. Operation 4. Pressurization of the reaction vessel. Upon opening either MV4 or MV7, carbon dioxide flows into the reactors. Pressure within the vessels begins to rise, either reaching 55 bar or matching the CO2 storage pressure if a recycle tank is in use. Operation 5. Pre-pressurization of the Cyclone. By pre-pressurizing the Cyclones, collection conditions are balanced, helping retain volatile components typically lost early in the process. This can be done by opening MV11. Note: to avoid creating a bypass that directs the collected materials back through the recycle line, it is essential to close MV11 before initiating the reaction process. Operation 6. Opening the vessel outlet. Once the vessels have been pressurized, valves, MV5 or MV8, can be opened, directing flow to the back pressure regulator. At this stage, the system is now primed, and it is safe to initiate the CO2 pump. Operation 7. Cyclone vessel. The flow of CO2 passes through the back pressure regulator, proceeding into the vaporizer, and ultimately enters the cyclone vessel. The vaporizer's role is to warm the CO2, which subsequently cools down as a result of the Joule-Thomson effect. This occurs due to the pressure difference between the system's reactive side and its less pressurized collection end. Operation 8. Draining the cyclone. Any material that accumulates in the cyclone vessel can be collected by opening MV10. When the cyclone is pressurized, the accumulated material is expelled through the valve into the vent box. Material can then be collected in an appropriate container positioned below the cyclone vessel. Operation 9. Venting the system. The system functions in two modes, based on the positioning of the valve, MV12. The position of the valve decides if the CO2 exiting the collector will be discharged into the environment or recycled back into the system, provided a recycle tank is in place. Operation 10. Venting the vessels. After completing the reaction process, depressurization of the reaction vessels can be accomplished by opening the appropriate vent, MV6 or MV9. The carbon dioxide is gradually released into the vent, which should be directed towards an area suitable for the safe release of CO2. Operation 11. Safety. To safeguard against overpressurization, the system incorporates multiple safety devices. In the event that the pressure surpasses the safe limit, the rupture discs swiftly burst, allowing for the rapid release of pressure.